All right, chapter 10. We have finally gotten to thunderstorms and tornadoes, right? What makes a thunderstorm? Well, officially, it's just thunder. And what makes thunder? It's this poster that's been behind me all class long, right? Lightning. You have to have lightning in order to have thunder, and anytime you hear thunder, you officially have a thunderstorm. So, what makes a thunderstorm, other than there being lightning? Well, it's just this bubble of air that's rising. That bubble of air rises because it's warmer, just like a hot air balloon. It's warmer than the air around it, so it's less dense, and it rises. As it rises, it is cooling. As it cools, its relative humidity goes up. You get condensation, and you get a cloud to form. That cloud then forms, precipitation processes begin to occur, and rain starts falling out of that. That whole process is a thunderstorm cell. And in a typical, just what are called air mass thunderstorms, just your popcorn thunderstorms that occur maybe on a hot summer day, that process takes only 30 to 60 minutes. Maybe that's fast to you, maybe that's slow. Some people just really don't realize that whole process is kind of in that 30 to 60 minute time period. And if you're lucky enough to get caught underneath it, you're in that underneath that rain, that down the dissipation phase. It's actually kind of ending once you start to get rain from it in an ordinary thunderstorm. So there's three phases to that. There's the cumulus phase, where that's growing. That's the beginning phase. There's the mature stage, where you've got rising motion and you've got falling motion. That falling motion is caused by rain. So anytime you have rain in a thunderstorm, or you see a cloud with rain falling, you are in the mature stage. And then the dissipation stage is when there's nothing but rain falling, or virga, rain that's not hitting the ground. And those are the three stages of your popcorn thunderstorm, just that cycle that takes 30 to 60 minutes. You've got cumulus, that's developing, mature, up and down motions, and then you've got dissipation, which is just downward motions. Okay, so we have this cumulus stage, this mature stage, this dissipation stage. We have this ordinary cell, this up and down. That is the life cycle. But obviously, there are different characteristics of storms. You don't just have this very simple up and down motion, and that's what creates tornadoes, right? There's obviously something else going on here, and that is something called wind shear. Wind shear, I'll get to it a little bit more specifically and in length a little bit later, but wind shear is just how the wind changes with direction or speed with increasing height above the ground. Okay, that aside, that shear will determine what type of storm we get. So, excuse my slight English infraction there. There are three basic types of thunderstorms. There's the single cell, which is what I just described, the cumulus, mature, and then dissipation. That's an air mass thunderstorm, or a simple thunderstorm. A single cell air mass thunderstorm. Then you have the multi-cell thunderstorm, when we get these popcorn thunderstorms, but they start organizing together to form these lines, usually what are called a squall line or complexes. That is a multi-cell, and that's more organized. Then we get to the special type that is called a supercell. A supercell is formed when the shear is the strongest among those three categories. Then you also get rotation because of that shear. The storm actually begins to rotate. Sometimes the entire storm begins to rotate, but usually there's a section of the storm that rotates, and you get a little hook to develop because that rain is wrapping around that rotation in the storm. And that's, maybe you've seen Twist or other weather movies, or you've seen it on TV with the weatherman. That is the hook echo caused by the rotation in the supercell. So three basic types: the air mass, the multi-cell, and then the supercell. So what is wind shear? Okay, in terms of thunderstorms, we're talking about vertical shear. And what shear is change in wind direction or wind speed with a change in height. Normally, there is wind shear. There's almost always wind shear in the atmosphere. That's just because the jet stream, the winds are higher or stronger above the ground than they are at the ground. So there's always just a little bit of wind shear out there because the wind speed is increasing with height. Okay, so that's almost always the case. But what we found through the years of studying storms is that storms need specific amounts of shear in the atmosphere, in order for them to take on certain characteristics. So under a certain value, air mass thunderstorms are to be expected. And you get above that certain value, and then you get into multi-cell. Those complexes or squall lines, or what are called training patterns of storms. Those are in a specific greater shear than air mass, but lower than the third class supercells. Supercells require the greatest amount of shear. Once you get to a certain level of shear in the atmosphere, you get a little bit more rotation in the atmosphere, and that's what causes the supercells to rotate. So shear is always present, but it's not always enough to cause severe storms, and that's why not every thunderstorm is severe. So how does shear actually cause certain storms to become severe? It's mainly because it allows the storm to continue ongoing. It allows the storm to not kill itself off. In an air mass thunderstorm, air rises, condenses, and then rains right back on top of it. And you need upward motion for a cloud to develop. So anytime you have rain falling on top of an upward motion, it kills the cloud off. So air mass thunderstorms basically kill themselves off. Multi-cell and supercell storms have a tilted updraft. What that means is the warm air rises and then falls. Let's see if I can do this right. We'll go this way. Rises, and as it rises, it falls away from where it rose. So you can keep getting upward motion and then it falls. Upward motion and then it falls. Upward motion. So it doesn't cut itself off ever. And because it doesn't cut off that warm air rising, that storm can keep drawing in warm air from around it. And so the shear promotes a tilted updraft and allows the storm to continue. And that's when the storms can get severe.